name is Harold York. I'm a research scientist in Pasadena, California, and I will be talking about how to calculate the speed of a moving object using the kinetic friction. So the situation we're describing is the case of something with a mass m moving, in this drawing, to the right with a velocity v0, and the forces acting on it are, on the one hand, gravity is trying to push it down. There's a normal equal but opposite force of the pavement or the ground pushing up against the mass, in. And then there's the frictional force, which is trying to slow this object down. And so we use the formula for kinetic friction, which means that this frictional force is equal to minus the mass times g, that's the normal force, times the coefficient of kinetic friction. So the object will slow down because of friction, and the acceleration of friction would result in a decrease in velocity. And the formula for that, we know that F is equal to ma. I set these two expressions equal, and for the acceleration a, I use the change of velocity with time, dv dt, and I come up with this formula which has the solution. The velocity as a function of time is equal to my initial velocity v0 minus the gravitational acceleration g times the coefficient of kinetic friction times time. And if we drew a graph of this, this shows the velocity as a function of time, starting off at v0. With time, we decrease our velocity until we come to the time t-stop, which means the velocity is 0. And that can be calculated again from this formula if we set v of t-stop equal to 0. We can also determine the stopping distance. That's simply the area of the velocity versus time curve. And since this is a triangle, it's 1/2 the initial velocity v0 times the stopping time t-stop. And putting this together, we can again substitute t-stop into the formula here, and we have a stopping distance d-stop equals 1/2 v squared divided by the product of gravitational acceleration g times the coefficient of kinetic friction. So this means when you're traveling in your car, if you move at a velocity twice as fast, you have 4 times the stopping distance. Also important in this formula is that the coefficient of kinetic friction needs to be as large as possible. You need to have good tires. The coefficient of kinetic friction is small and your stopping distance is large. So I hope you've enjoyed this discussion of how to determine the velocity of a mass being acted upon by kinetic friction. And that's it.